When we know that data are normally distributed, we can easily calculate percentile ranks for scores in the distribution and percentiles of the distribution. The percentile rank of a score in the distribution of data is the percentage of data in the distribution that is below that score. For example, suppose that a score of 40 is above 65% of the scores in the distribution. We say that the percentile rank of 40 is 65. The percentile of the distribution is the score in the distribution that has the specified percentage of data beneath that score. For example, a score of 40 is above 65% of the scores in the distribution. That means that the 65th percentile is 40. Let's see how we can use R to calculate percentile ranks and percentiles on a normal distribution. SAT data follow a normal distribution. Here are the SAT data from the 2014 administration of the test, displayed with a histogram. We can model these data with a normal curve. We will now use this model to calculate percentile ranks and percentiles. Let's start with percentile ranks. The function in R for calculating percentile ranks of scores in a normal distribution is p-norm. You can think of the p as standing for percentile rank and the norm as standing for normal distribution. I want to know what the percentile rank is for an SAT score of 1200. I supply the score of 1200 as the first parameter for the function p-norm. The next two parameters for the function are the parameters of the normal distribution. In this case, the mean of the normal distribution is 1497 and the standard deviation is 322. When I run this function, R calculates 0.178, or about 0.18. This means that the percentile rank for a score of 1200 is 18. That is, 18% of the data in the distribution are below a score of 1200. If we wanted to say this using the term percentile, we would say that the 18th percentile is 1200. Let's now find a percentile rank for a score of 1600. Again, I use p-norm, this time with a score of 1600 and the mean and standard deviation of the normal distribution. The result is about 0.63. The percentile rank of a score of 1600 is 63. That is, the 63rd percentile is 1600. Let's try 1800. A score of 1800 has a percentile rank of 83. The 83rd percentile is 1800. Now let's do this the other way around. That is, let's give R the percentile rank and ask it to find the score that has that percentile rank. The function for doing this is Q-norm. The Q stands for quantile. That term is more general than percentile. When we divide up a distribution into 100 parts, the score corresponding to each division point is a percentile. If we divide up a distribution into 4 parts, the score corresponding to each division point is a quartile. Percentiles and quartiles are special cases of quantiles. R uses the more general term quantile. We can use this function to find percentiles or quartiles since they're special cases of quantiles. Let's use Q-norm to find the 40th percentile. The first parameter for the function is the proportion 0.40. The 40th percentile will have 40% or 0.40 of the data beneath it. So we need to provide 0.40 as the parameter. The remaining 2 parameters are the mean and standard deviation of the normal distribution. When we run this, we get a score of 1415. The 40th percentile on this distribution of SAT scores is 1415. Let's find the 65th percentile. This time we put in the proportion 0.65. The function returns 1621. The 65th percentile is 1621. Now, as it happens, there is no such thing as SAT scores of 1415 and 1621 because SAT scores are in increments of 10. But note that we're using a normal distribution model that is continuous. That means any score is possible on this model. If you prefer to report your percentiles as actual SAT scores, you can simply round to 1410 and 1620. If we know what normal distribution provides a good model for our data, we can use the p-norm and q-norm functions to obtain percentile ranks and percentiles of the distribution. In the not too distant past, to calculate percentile ranks and percentiles, students would have to convert the scores on a normal distribution to z-scores on the standard normal distribution. Then they would use these z-scores to look up the percentile rank or percentile in a table. Believe me, using R is a whole lot easier. Try using these functions. I predict that before long, you'll feel comfortable calculating percentile ranks and percentiles.